Hey guys, welcome to lesson 3.1.3. We are going to still continue with rewriting to solve and showing whether two functions are equivalent. There's just a few slightly new things that we're going to talk about today. First, let's go ahead and do something we've already done before, which is graph the functions to see if their tables seem to be equivalent. So in the calculator here, I have gone to the y equals and already typed this first f of x function out for us. So we can go ahead and go straight to the table and see what the values are. Oops. All right, so we can see our table right over here. Our table on the worksheet starts at 0, so that's the numbers we'll follow. We have negative 15, negative 24, negative 15, negative 24, and negative 27, negative 24, negative 15, and 0. All right, so that's our first table. Let's go ahead and graph the second equation now and figure out what the table is for this one. So we have to type it exactly as we see it. X minus 5. All right, by now we should be very comfortable with doing this. If you're not, please reach out to me. Okay, so here's our table. Here are our new values. So looking at this, again, we'll look at this one down here where it starts at 0, negative 15, negative 24, negative 27, negative 24, 15, 0. They match the first table. So we can go ahead and fill in the rest, or fill in the other table. And we know that the tables at least seem to be equivalent. Okay, and also check the graphs too. Remember that graphs are also a way to check for equivalence as well. Here we have the first graph. It's not the best view of it, but we can see some of it, and we can type the other one back in so that we can do them both at the same time and see where they land relative to each other. Okay, so the new one, notice how the new graph is going to graph right on top of my original one. So these are signs, the table and the graphs, that these two functions are equivalent. However, you never know if, somewhere down the line, closer to infinity, something gets changed, right? Something's different. We cannot be 100% sure that they are equivalent, even though what we see on the graphs and tables are, because you just never know what will happen. We're only seeing a part of the picture. So the algebraic route is your best bet in terms of rock-solid proof that functions are equivalent or that they're not equivalent. So here's the deal. We can either factor this first one to see if we get the second one, or we can multiply out the second one to see if we get the first one. We're going to do the method where we multiply the second one out. Now, this is nothing new. However, there is one small difference in this one compared to the other ones we've been doing like this, and that is because there's a 3 out front. The thing about this 3 is that we have to distribute the 3 into one of the sets of parentheses before we can do the generic rectangle and use the box. Okay, now the most common mistake I see is when people multiply the 3 into everything. Okay, do not do that. Okay, if you do that, that'll be like multiplying 3 into it twice. So it's actually like multiplying a 9 in there. And the thing is, when we multiply it only into one set of parentheses, it doesn't matter which set you chose. You could have chosen this one too. It doesn't matter. I just choose this one because it's closer. At the end of the day, we are going to multiply these parentheses, so that 3 that I only gave to the first set is going to get multiplied to the second set. So don't go jump the gun and multiply the 3 into both sets of parentheses, because that will not be good news. All right, so now that I have this is what I will put in my, on the outside of my box. Okay, so let's go ahead and multiply these out. 3x times x is 3x squared. 3 times x is 3x. 3x times negative 5 is negative 15x. And 3 times negative 5 is negative 15. All right, we're almost done with that here. We just need to make sure we note that we do have some like terms. These can combine. Negative 15 plus 3 is negative 12, so we have a negative 12x there. Now we can say that the entire sum is 3x squared minus 12x from those combined terms minus 15. So now you look at this and you say, is this the same thing as f of x up here? And sure enough, f of x is the same exact equation as what we got down here. And that is how we know for a fact that they are equivalent functions. All right. Moving on. Here we have an equation that looks like stuff we've already done before, you know, the factoring and the quadratic formula problems, but there's something I want to point out here. If you look at these terms, you should probably start thinking, like all of these three numbers look like they're all divisible by something. A little bit of thought should give you the result that you could divide all of these numbers by 5 pretty nicely, okay? So what we're going to do is go ahead and divide them all by 5, and we're going to factor out a 5. So when we take the first term and divide it by 5, we just end up with x squared. When we take negative 15x divided by 5, we end up with negative 3x. And when we do 10 divided by 5, we get 2, positive 2. Okay? And if you're ever unsure if you did your division right, you can always try multiplying the 5 back in and seeing if you get this original equation that you started with. All right, so now, because we factored out a 5, my numbers are much smaller and much easier to work with. So we can go ahead and do the box and diamond and figure out what our factored form is. But we're going to do it to this equation, not the original. All right, so as usual, the first term goes in the top left and the third term goes in the bottom right. In our diamond, we put first times third, so 2x squared. In the bottom will go the middle term, so negative 3x. All right, so then you have to ask yourself, what two numbers multiply to make positive 2x squared and add to make negative 3x? Hopefully you would come up with negative 2x and negative 1x. And so we'll fill the rest of our boxes with those. All right, so now we can go ahead and do the outside of the boxes. So we have x and x must make x squared, x times negative 2 to get this, x times negative 1 for my negative 1x. And now, here's the deal. Traditionally, you probably would just take the outside of the box and say, okay, well, here's my factored form. However, do not forget that we factored out a 5 in the very beginning. So do not forget that we have to put that back in. All right, so really our correct factored form is 5 times whatever we got from our box. All right, now let's not forget that the problem originally asked us to solve the equation. So once we get to this point, we still have to finish off the process by setting each factor equal to 0. And then you get an answer of positive 1 and also positive 2. All right, so the only new thing about this problem was that we looked for a number that we could divide all three of these terms by to make our lives a little easier when we were factoring. Okay. So this next problem, it kind of looks like it tried to be something we could factor, but there's something missing, right? You look at this one and you're like, okay, there's 3 terms, x squared, x, no x's. And this one kind of tried, but it's missing an x term, right? This one had a negative 15x. This one has no x's. So what we can do in that case is we can rewrite this in kind of a manipulative way so that we can factor this with box and diamond just like we're used to. Okay, so if there is no x term, technically that means we have 0 x's. So we could just throw in a plus 0x there to give ourselves an x term. Now that we've made the equation look like this, we can go ahead and box and diamond like usual. All right, and go ahead and factor this. So 2x squared in the top left, negative 2 in the bottom right, negative 4x squared in the top from first times third, 0x is going to go in the bottom. Now you got to ask yourself, what two numbers will multiply to make negative 4 and add to make 0? Well, that would be negative 2x and positive 2x, because negative 2 plus 2 is 0. Negative 2 times 2 is negative 4. So we'll go ahead and fill in the rest of our boxes and fill out the outside. So here, because there's a 2x squared in this box, we need a 2x times an x. We can go ahead and put the 2 up here. This is a unique situation where we actually could have put the 2 on either side. Usually we can't do that. You have to pick the correct one. In this case, it goes into both of these red terms, so it wouldn't matter. So 2x up here and x over here. 2x times what gets us negative 2x? That would need a negative 1. X times what gets us 2x? That would be a 2. So we are ready to write our factored form. All right, and again, just like the last one, remember we are asked to solve this equation, so you have to set each factor equal to 0. This one's real quick. We know we would add 1 to both sides. You'd get an answer of 1. For this one, it takes a little bit more work. Subtract 2 from both sides, and then divide both sides by 2 to get x finally by itself. We get a final answer of x equals negative 1. All right, that is all for today.